Good morning, everyone. I'm going to kick off this one. Dore is having some issues with getting his presentation up, so maybe I'll just get started and go over a few things that I was going to go through before I turn it over to Dore. So, so welcome to this session, right? We wanted to have a session on API security that was more comprehensive. Think of it end to end, right? From that first touch on an API all the way to an access and everything in between. What do you need to do to really protect yourself, right? And have proper governance. So we know hackers love to breach APIs. Quite a few examples out there these days. We know also it's not just about hacking, right? You have partners who do stupid things on API, and you got to protect yourself against that. And then you have those who leave APIs out there with, I would say, great vulnerabilities that ethical hackers will find and then report to the press. So very embarrassing, brand tarnishing, right? And ultimately, right, this is what you're trying to prevent. You want good APIs out there. You want to be able to monitor them and prevent hacking, right? So it's about API governance. So good API governance is about a strong capability to monitor all access, all activity on APIs. So you can report on it, have forensic data, and so forth, and the ability to monitor anything for abnormal situation, right? So that's really your holy grail. You want great API governance, and if you do this, you'll be able to detect abnormalities, including hacking. So hackers are getting pretty smart about this thing, right? Yesterday I had a session on hackers with stolen credentials and how you can protect yourself from it. And if you wanted to reach out to me for more information on that, I'd be happy to go through that with you. But most of the time, right, hackers just grab an account. They go to the bank, sign up, new account at the bank, new account at a healthcare provider, the retailer. They just sign up, right? Social, right? Facebook, Google. They just sign up, and then they use that account to work on the API. They reverse engineer the API. They bypass the UI, go straight to the API, look for that vulnerabilities, and then breach, right? But it's not just breaching. It's in a retail account. It could be that they are manipulating the pricing. We've seen that, or the inventory, or they are capable of getting gift cards and so forth. So hackers are pretty smart, right? And then you have the other problem, which is non-hacking. Partners have valid credential. A great example of a crazy situation really was the Experian one, right? End of last year, one of their loan broker used an Experian API, which was meant to be internal, shared with them, right? So it's internal to the ecosystem of Experian. But this loan broker thought it would be a great idea to have a promotion on his website and use it to have people check their credit score. Well, unknown to Experian and obviously unknown to the partner, there was no security on that API. And so anyone could get this credit score of anyone with a name and a physical address. And that exposed literally the PII data for millions of Americans. Some people say all Americans that have an account somewhere, anywhere, reported to the credit companies. So talk about an embarrassment, all right? So it's not just about hacking, right? And then you have those bugs that really get you in trouble because, hey, 99% of the time, this API return data with a proper token. And then 1% of the time, it's going to return data with no authentication authorization check, right? Nothing, a bug. So how do you deal with these things, right? So the best, what we talk about usually there are two big gaps. There's a visibility gap, right? Where you have APIs in one or more data centers, one or more clouds, and most people are unable to understand how that traffic across all of these APIs, across the clouds, the data center, actually relate to human beings or machine, because usually they track IP addresses and tokens. But if you are in San Francisco, accessing APIs in Houston, in AWS, APIs in Boston, most people just don't know that, right? It's API gateway by API gateway. So the lack of global visibility, single pane of glass, tying the traffic to user identity, knowing about your forgotten APIs, the APIs you don't know about, shadow API, that's a big deal. That's what we call the visibility gap. Need to address that. Second one, security gap. Most people rely today simply on their WAF and WAPs, and we know it's not enough, because WAF and WAPs rely on rule-based recognition, meaning they have to have the template. They need a signature to recognize something. So an API attack tends to be freestyle. It's custom to that API. Every API is different. So WAF and WAPs are unable to really detect those API attacks. And positive API security is not enough. This is where you make sure this is the right method, the right payload, and so forth for that API. So I let it go. Wrong method, wrong payload type. I'm expecting JSON, is coming with XML, I'll block. But like a very well-known industry analyst said to me a couple of weeks ago, WAPs and WAF should not be, I would say, super excited by what they block. They should really be worried about what they let go. And that's really the security gap. So you need something more than that. Dore will get into this for us in a few minutes. And then the last piece before I pass it on to Dore, and obviously I'm hoping that Dore has his presentation ready to go, is how do you go about it, right? You need to have a method, a goal for implementing, tracking and abnormality detection. The best way to go about it is the zero trust model. You need to authenticate strongly every access, right? And simply to, if you use MFA on authentication, you'll get rid of hackers that have stolen credentials too. And then past that authentication, as you authorize access to an API, you have to be able to monitor all API accesses and identify abnormalities. So that's the key. So Dore, I think that you're still not ready. Do you want me to try to share it for you instead? I could do that quickly. You want to try that? All right, let me do this. Okay, hold on, guys. I'm going to do this. Going this here. Okay, can you see the whole screen? I might need a text from you, Dore, at this point. Hold on, let me check. Okay, so Dore, why don't you go ahead, and I'm gonna get it to your slide, and then you just tell me next for each slide, and I'll pass them on. Okay. All right. So Dore, take it away. You might be in mute, Dore. Can't hear you. Okay, looks like Dore is having a ton of technical problem. Let me take a stab at these slides. You just can't unmute for some reason. Maybe Dore, you just reboot your Mac and we go from there. Okay, so quickly, for sake of time, right? I'm going to go through those slides, and so So remember the last point I was making, right? Adopt a zero trust model, right? Where you authenticate everything strongly, and then past the authorization step, you continuously monitor everything that's going on, right? So we're going to actually go through this over the next few slides, right? So number one thing you need to think about, right? You need an anti-bot system, right? You're going to have this on your APIs and DDoS, obviously, right? And it's part of getting rid of all this stuff that's going on your authentication. It could be credential stuffing attacks and so forth. So authentication and authorization, believe it or not, these are the two biggest issues still today with APIs, right? The lack of proper authorization. The OAuth top 10 calls it the BOLA, right? Broken Object Link Authorization. And it's a big deal, right? Because someone comes in, accesses his account, and suddenly has access to everyone else's account. Think about the Peloton bridge when they say, hey, everyone can get to Joe Biden account. That's what happened, right? Lack of proper authorization is a big deal. It's probably the number one cause of grief with API security. Obviously, token validation is big. Payload inspection is big too. You have stuff coming over the APIs, and you need to know is there API data that shouldn't be going, right? As a user consented for this data to leave. So that's important too. And then the key, right? Addressing the visibility gap, addressing the security gap means you can monitor all activities, you can report on it, you can detect anomalies. Most important, you got to be able to remediate, right? You got to be able to say, block this user, or hey, I'm not confident that something did not happen since the authentication, re-authenticate, or just bring an MFA step up on that guy. I'm getting a weird, I'm in different location, the IP address has switched, just step up the MFA just to be safe, right? So it's the kind of rules you can build into your system, but remediation, in this case, those steps is really, really important. So this is broadly how you go about these things. Now, you have different systems that take care of different things, right? Typically, bot detection will be done at the WAF or CDN level, WAF or WAP, or sometimes you don't have a WAF and you buy a good anti-bot detection from someone. Ping offers that too. You can get it from other vendors. We have some really good partnership with F5 ourselves. But look, you need one of those, right? Then access management is all about your IDP, right? So it's Ping or someone else, but it's proper authorization and it's proper control over what gets access. The API gateway will enforce the authorization, right? This is where the token is minted by the IDP according to the access management policies that are in place. And then the API gateway will double check this token to make sure that the scope, the rights that you have now are handed over to you when you access the API and the resources behind it, right? So this is typically how it plays out in your environment. And then you want total token monitoring across, obviously, right? So ideally, and we'll talk more about that with AI, right? So anti-bot, right? So anti-bot today, a quick thing is typically done by looking at device attributes, right? Is this a device or is this a virtual machine that the hacker is running on a server with 200 other virtual machines, right? Or each pretending with a browser to be a PC. Or check the network attributes, right? This is coming from an IP address with a bad reputation, a network that's a bad reputation. So typically, everyone looks at that. At Ping, we look at it beyond that, right? We look at the actual behavioral navigation, right? The kind of stuff that only a human being leaves a good print on things, right? How you go across the screen, the kind of things it clicks on, the same thing with the biometrics around the mouse and keyboard movement. So we take all of this into account to determine whether or not this is a bot or an emulator or a bunch of tools a hacker is using to bombard your APIs. By the way, what do they do when they bombard your APIs, right? It's typically a bunch of credential stuffing. They're trying to guesswork what your password and user ID might be. Remember, if you have an MFA, you can block that, right, as well. But let's say the bot got really lucky, right, and they managed to get in, they found a credential, and now, right, typically sometimes the credit card is on file, right, and all they have to guess is that 3-digit code on the back of your card, and they can do that very, very quickly, and use that account and that credit card to purchase stuff, right? So bots can be a real problem for a lot of people, despite just think about it, right? If you have lots of bots on your API, they're probing like crazy. It's like a DDoS attack, ultimately. All right, so moving on. For the sake of time, maybe I'll go very quickly through this. At Ping, like most anti-bot solution, we use a Java SDK, your Android platform, your iPhone, your regular PC, laptop, browser, and we work with the retailers typically to understand all the traffic hitting them, and then retailer or financial institution or healthcare institution or manufacturing, and then we provide all that data to block those bots. Okay. So let's talk about access management. So access management, that's how we call it at Ping. A lot of people would think about it as authorization management, especially in the gateway world. It's about how do you federate the authorization across gateways, right? It's becoming more and more of an issue, right? It's about minting token, but are the token being minted according to what a developer has decided and so forth with someone, or do you give someone the flexibility to create policies so you have a broader, I would say, unified implementation of what people can do over what APIs and what resources behind, right? So at the end of the day, right, when it comes down to application access, the developer tend to build that in. It's rigid, it's difficult to modify later. The business owner tend to want to be able to, I would say, adapt those according to the business need at that time. So ultimately, you need to provide those teams with simple tools that allow them to have decentralized, uniform, auditable set of accesses across APIs. So at Ping, we have a SaaS-based system that allowed you to federate this authorization across multiple API gateways and cloud and so forth, so that it's really much simpler for teams to collaborate and enforce, right? And this is becoming more and more of an issue as the API deployment have reached exponential level these days in terms of what's going on, and it's going to continue, right? So having this capability to have centralized access management, centralized authorization management, federated across is key. And we provide this as a service, a cloud-based service to simplify things. We have it also on-prem, by the way. We have both, so lots of flexibility for hybrid environment. So, and here's a quick environment there. I won't bore you with the screen, but this is an open banking use case where we centralize and federated, but more importantly, everything become auditable, right? It's going to become more and more important to everyone. But the key is give the business owner or give the people who control those resources behind the API the ability to modify access without having to know anything about the API itself, right? All right, let's move on. Let's talk about dynamic authorization. And we just talked about authorization, right? What is dynamic authorization? So dynamic authorization goes one step deeper, right, in a way. You can think of it as dynamic contextual authorization, right? So it's not just a blanket authorization. John Smith has access to this API. It's not that, right? It's John Smith will have access to this API if he was given consent by the person who owns the data associated with this account. So context is everything in what we think of dynamic authorization. So think of it, it's deeper, but contextually, right? It's a layer above this authorization, right? Which means, yeah, John Smith has access to the authorized to this API, but I'm going to limit what it can do depending on the context, right? That's how you should think of it. So now the big deal is that the business team really want to control over this, right? And there are many examples here, but they want to control this. Let's say it's a healthcare environment, right? And you know, in the US, right, the Cures Act happened. Every data exchange needs to happen over API, including getting access to anyone in a healthcare, right? A doctor, a clinic, an insurance provider, access to patient data. But you need consent, right? So think about it, right? You'll give access to this API to whoever needs it, but the context would be, do you have consent, right? So transaction details matter too. Another example is banking, right? So John Smith or let me take Mint can use John Smith's account to do certain things, right? So John Smith has given Mint access to his account and so forth, and he can do this. But depending on the transactions that are being performed, the transaction may or may not be granted, right? Authorized. So another example, right? So contextual authorization is one layer above just blanket authorization, right? You cannot just do anything on an API just because you have the scope to get and put and post and so forth. You need a little bit layer above, now think business, to control that. And if you think about it, right, it's really a set of policies at that point that a business owner can control. So that in the case of a payment here, right, another good example, you could say, hey, yeah, every payment below $5,000 is authorized, is permitted, just go, right? Use the API, do all this transfer all day long. But the moment it's over $5,000 and let's say maybe over $10,000, over $20,000, it's like, hey, stop there, right? We need to double check stuff before we authorize that one, right? So you can see it's not a blanket authorization to do stuff. So now what will you check? It could be, hey, before I do this, I'm going to validate again with my system the target account. Is it the same target account usually this person is using, or is it a different target account? It's the same one, okay, maybe last week. Different target account. I'm talking about the target banking account, right? I may not want to let that happen. Or I'm going to check the risk, right? I may use the ping one risk assessment, which is the user risk assessment. Think about UEBA, what location is it from? It's different location. And then when I'm satisfied, I'm going to let that happen. So you can see how authorization can have a fine-grained dynamic step. It's all real time, right? That's why the word dynamic. It's all real time, in the moment, quick check, let it go or block it, right? So that's what it is all about. At the end of the day, right? Again, right? Typically these days, the application developer would be building in as much of this into the application, but it's really static and flexible and doesn't map to what the business needs anymore, especially as more and more of those APIs get rolled out. So policy-based management, think UI that allow a business team to apply rules by simply going to a UI and saying, I'm going to let this happen when this is true, or don't let this happen without checking the user consent, or don't let this happen without an MFA, or don't let this happen if this is a different target banking account. So you can see how it's a layer above, but it solves a ton of problem very quickly for the business, right? Ultimately, deploying APIs, making use of API is about an ROI. We all know about the API economy, right? And so this is about bringing a higher level of ROI with a higher level of security, right? And that's the thing to remember. Okay, so if you have one takeaway here, think about what Ping called fine-grained authorization, dynamic authorization. You can think about it as authorization within a context. And if I see the right context, I will let it happen. All right. Let's go to AI-based monitoring. It's back again to, now I authenticated. I make sure I don't have a bot, right? The bot is out of the way. It's not a bot. I authenticated. I now have authorized the user to access something. And now I got to really track what the users are doing, right? Among those users, I could have either a partner misbehaving, or I could have a hacker that has successfully got in. Maybe he has stolen credentials, right? And my organization didn't do an MFA prompt in front of him. Remember, the good news about MFA prompt is that the MFA prompt will go to the owner of the credentials. The hacker will not have his phone, right? So the hacker will not be able to handle that request for another step of authentication, something he owns, the phone, or biometric, or FIDO2 key, right, with a PIN. He doesn't have that. So an MFA would block a hacker from coming in with stolen credential. But let's say he got in, right? So now, first thing, visibility, and it's paramount, right? Do you have an API that I forgot? Because an API forgotten is easy, right? I rev this API, new application. I left the old API on for backward compatibility, right? I need it for a while, and then I forgot it. And we know of numerous cases where the hackers have found those APIs and used them to breach. Okay, so you got to know that. And then you have the APIs that someone put out there because they're trying something. They didn't report it really to the security team or to the rest of the team. And it's a shadow API. And maybe it's just an internal API. But remember, right, you have to treat all APIs as externally facing, because this concept of perimeter is gone now, right? That's why the zero trust concept. So at the end of the day, shadow APIs, or what people call zombie APIs, forgotten API, will get you in trouble. So you got to know about all your APIs, and discovery is key. And then you have to be able to track the traffic, right? Then you have to be able to understand if the behavior on that API is normal, right? Is there something weird about it, right? And that the case of a partner that just repurpose an API, right? And then obviously the big security gap. How do you apply AI techniques to bring a layer, right, to do more stuff? Okay, so in a nutshell, right, if you think post-authorization, what you got to do? Strong visibility, strong security, and see if you can detect stuff in production that relate to bugs and implementation issues with the API in production. I'm going to go through this fairly quickly, but it's amazing to me that still today, so many IT teams we meet still believe that their WAF is going to be enough to protect them, right? And we know that, just like us here and all the vendors that are part of this conference today, and many other and analysts and so forth, everybody is on I would say an evangelism mission to get people to understand that WAFs and WAPs are just not enough, right? And the big reason is they are rule-based. And how is that going to help you when a hacker came in with valid credentials? How is it going to help you when a hacker just sign up with Peloton, get an account, jump the UI, and start to access everybody's account? How is that going to help you, right? It's not going to help you at all. This is rule-based. I'm looking for SQL injection. I'm looking for cross-site scripting attack. I'm looking for stuff I already know. But when a hacker goes on, or a partner, let's say a partner repurposed an API, he took that Experian API and put on his website. How is that going to help you? Yet for Experian at least, right? Millions and millions of American citizens, private information were exposed. So not enough, right? You need much more than that. And to catch this, right, you need AI, call it ML, right? We always call it AI ML, but it's truly ML. So you need ML capabilities to detect the unknown, to detect stuff you're going to learn on the fly at that moment, to counter those issues with recognition. Hey, oh, wait a minute, that Experian API that just get on that website is now seeing a ton of activities, and I'm getting a lot of stuff, and it's like, oh, this is not normal. AI will recognize that, right? Simple example, but just to make a point, right? What if it is a hacker that's coming in and manipulating the pricing for retail store online, so you could buy a bunch of stuff at low price and possibly return it later at a regular price, right? So think about it, right? And then the big deal, at least for me, I believe, especially for many of our customers, we're dealing with multiple data centers, multiple clouds, is this concept of tracking all activities linked to the user identity, right? You need this for governance. What did John Smith do across these 3 AWS API and these 2 APIs in the Houston data center? And give me all the traffic. And I detected an issue. Let me know what it was about. So gateways, as you know, at Ping, right, we're well known for the integration with API gateways. We have, I think, I don't track well anymore, but I think 16 or so, 15, 16, 17. Don't hold me to that count, but it's roughly that, right? Integration with API gateways, which means the API gateways see all the traffic correctly. We take a view of it, and we're able to bring a layer of security on top that is really about detecting all of these abnormal situations, right? Is there a data theft at play right now, right? Is someone taking over an account? Is someone right now manipulating the pricing for that retail store, right? We bring all of this knowledge that only AI can bring to it. Plus, we are able, especially most customers today have multiple API gateways, or at least one on-prem and AWS or Azure or RPG GCP in a cloud, right? Then you are able to give this visibility across all API gateway, again, linked to the user identity, right? So it's a tremendous value add to API gateway. And that's why we have so many great partnerships with so many TIBCO, Axway, and WSO2 and Kong, and the list goes on, right? Nginx, and I'm going to, obviously, I don't want to list everybody, I don't have the time, but come to our website, you'll see the 15, 16 there. Okay, so what do we provide at Ping, right? So we provide the ability to give you that single pane of glass and unify all that traffic linked to the user identity, right? And then we dynamically discover your APIs, right? Those forgotten APIs, those shadow APIs, and so forth. So we can give you the list, you can categorize them, and so forth. The big deal is the security gap, obviously. So AI can be used to identify a whole bunch of stuff that are happening in production. I have a few more slides coming on that. So, and then obviously you have to be able to remediate and block stuff, right? That's really important. So discovery, right? It's about, hey, I discovered this API. I can see the specification for that API. I'm going to group them. So you can see these are all the APIs in London, or these are all the APIs for this retail store catalog, and so forth. So you can catalog them and you can track them that way. And then we can generate reports, right, per API activity. You can get it per user. You can provide insight. The big deal really is about delivering governance reports, right? You got to have forensic if something is going wrong. And we don't have the time today, and we don't have the time to put a demo together. I mean, we had the time to put a demo together, but we don't have the time to show it to you today. But we're going to jump into the AI stuff. But let's say we detect something, right? It's at time 0, we detected, or time whatever, 21:05 hour, we detected something wrong. In fact, we flagged it and maybe have blocked then the user, right? And then you want to know what happened. So we're going to tell you what happened. We'll give you an idea also of what you could possibly do to fix it, right? But we will also give you the last few request response that traffic, right? Detailed, right? With a header and so forth, that we're flying through just before we recognize that abnormality. So that's part of the forensic as well. So talk about AI. So AI is about learning what is normal, right? And we do a lot of learning, obviously, with AI. We learn what's normal with the API. How does someone normally use that API, right? And those resources. Then we do what is normal for these users, right? And what is normal for someone to access multiple API at the same time. So we do a lot of modeling across. Obviously, it's used to detect deviation, right? If someone deviate from the normal range of activities and so forth, right? And then remediation, which is really clear. You got to be able to do something if you detect something is wrong, right? If you cannot do anything, you just flag it. It's going to go to your Splunk system or other thing. Hours later, someone will wake up and say, "Oh, we had an issue," right? So you got to be able to have real-time blocking if something is terribly wrong. So AI is really based on understanding anything around the behavior, right? The behavior on that API, the behavior of the user on that API, and the ability to recognize a whole bunch of stuff that are wrong with that API that are not just about hacking, right? Again, right? So if you have an API that is vulnerability, call it a bug, who in 1% of the cases will return data, a payload, a response without a valid token, then that's bad, right? Because then the hacker will figure out, hey, if I do this and this in this sequence, I'm going to get a payload without an authentication, an authorization, and I'm going to take it, right? So catching this kind of behavior before they get exploited is important. So this AI is about detecting abnormal situation, vulnerabilities as well. Okay, and then you have the ability to, and that's very key, right? By tracking users too, right? So modeling the user, modeling the API, big deal. So here's an example, right? With token refresh, right? A user maybe over the length of a short session, especially in banking, use 3 tokens. If you have typically tracking stuff, you see what's going on per token. You're not going to see it across 3 tokens. If you can link those 3 tokens, right, to that one user, you can now detect abnormality for that session. So think about session abnormality, not just abnormality for the duration of that token. And you're going to learn a lot more about what's going on. And let's take the case of another API access with, in this case, 6 IP addresses, 1 token. That's not normal either. Obviously, you're probably dealing with a case where someone is hacking. And we've seen that, right? So we've seen hackers on APIs using a large number of IP addresses across a couple of APIs, obviously large number of tokens. But how will you detect this if you just look at everything per IP address or per token? You're not going to see anything because each IP access was normal, right? Remember, OAuth is only looking at IP address as well, right? So it's really critical to have the ability to associate all that traffic to the user and do the AI work. You do it anyway at the IP and token level, but do it also at the user level, taking into consideration all the token and all the IP addresses. And now you're going to catch hacking, okay? For the sake of time, I need to pass through the next few things. So remember, right? I want to leave some time for question. So remember, right? Anti-bot and DDoS, right? You got to have DDoS, but you need anti-bot. You need to strongly authenticate. You need good access authorization enforcement and management. Policy-based, right? You got to be able to do stuff in context with consent sometime, right? So this is really key. And we talked about that, right? And we talked about token validation, payload inspection. So same thing. I didn't go too much into this, but both the access and authorization product that I talked about, ping one access, ping one authorization, will let you actually on the fly, on the API, monitor the payload, recognize if PI data is leaving, but more importantly, can do a real-time check right there at the API to check whether or not the content in that payload was consented by the owner of the data, right? Open banking, healthcare, Cures Act, two great examples of the need to check for consent, right? So payload inspection is not just, hey, is there PI data and I'm gonna block it if I see PI data. Maybe PI data on that payload was okay and normal because that's what the user did. But doing it in context, right, which is something that we do as well at Ping, is key. Did the user consent? And we can do this in real time with that API gateway, right? Looking at the traffic, quick time, check consent, no consent for that payload, then you either obfuscate it or block it. That's the two things we can do. The user, this is a user who has an account at a healthcare clinic. He did not consent to have his lab from last year accessed by that person. It's redacted on the fly. So it's a great capability, as you can tell. Next, monitoring, global monitoring, global visibility, single pane of glass, monitoring with AI for abnormal and remediation, right? So if you do this, right, you will have really strong end-to-end API infrastructure protection, right? This is how you secure your digital transformation project. And remember, right, if you have that MFA out there, and especially if you use risk analysis on the user, you will get rid of a ton of hacking right there upfront, right? The guy is coming from different location, different device. He has a different IP that we've never seen. You line it up. That's going to force a prompt on the step up MFA, right? FIDO2 is key to everyone. It should be implemented by everyone, by the way. It's just key. And most vendors will now implement FIDO2 use the FIDO2 implementation of device either by Google or App or to use biometrics, right? Anyway, that's very key. And that's my summary. And I leave you with a couple of email addresses. If you really need to get in touch with us, use them. I am on Twitter as well, Dore as well too, but reach out to us, right? And yesterday I had a good talk on how to stop hackers with valid credential. And so if you wanted to deep dive into this, I could do it one-on-one with any one of you. Thank you very much. And I'm going to turn it over to questions.